In this video, I'm going to review how to multiply radicals. When you multiply radicals, you're actually using the product property. So if you take a look at the product property right here, the product property states that if you have the nth root of a and times the nth root of b, you get the nth root of a times b. So if your indices, which are these n's right here, are the same, you can just multiply what's under the radical, and that is your answer. So just a reminder, after using the distributive property when multiplying, you have to look for like radicals to combine and radicals that can be simplified. So let's go through and work a couple of examples here. All right, so we're going to distribute radical 2 across these two terms right here. So radical 2 times radical 6, they have the same index. They're both square roots. So I can multiply the 2 and the 6 underneath to get radical 12 minus radical 2 times radical 3. Again, they have the same index, so they can be multiplied underneath. 2 times 3 is radical 6. So let's see if we can simplify these radicals. When I simplify 12, I get 2 times 6, and 6 is 2 times 3. When I simplify 6, I get 2 times 3. In the first radical, I have a group of 2 that can be moved out, so I get 2 radical 3. And in the second one, I don't have a group of 3, so it's just radical 6. And when I look for like radicals, I notice radical 3 and radical 6 aren't exactly the same, so I have no like radicals. So let's try that again. Radical 7y, I'm going to distribute across both of these radicals. So the square root of 7y and the square root of 7, they are the same radical, the same index because they're both square roots. So I can multiply what's underneath. 7 times 7 is 49y. And then a square root and a square root multiplies to 7y squared. 7y times y is 7y squared. When I reduce these, let's see if they reduce. 49 is 7 times y, and then 7y squared is 7y times y. So I have a group of 7s in the first one and a group of y's in the second one. So I know the 7s come out and the y's come out. So I end up with 7y minus y radical 7. And the radical y and the radical 7 are not like, so that is my final answer. Let's move on to the next set of problems. All right, so in this one, I'm multiplying two binomials. All right, so I'm going to distribute this first term across both terms in the second binomial. So square roots are the same indices, so I can multiply the numbers underneath. 3 times 3 is 9, so this is the square root of 9. And then 3 times 15 is 45. So that's a positive radical 3 and a negative radical 15. So that's going to be a negative radical 45. And now I have another term I need to distribute. This radical 15 I must distribute across both terms. So it's a negative radical 15 times a positive radical 3. So 15 times 3 is 45. So that's going to be minus radical 45. And then when I do my last terms, I have a minus times a minus, which is a plus. And then I have 15 times 15. I'm going to write it as 15 squared because that'll help me reduce in a second. So 9 reduces to 3 times 3. 45 reduces to 5 times 9, and I know 9 is 3 times 3. So I have that again, 5 times 3 times 3, and I know 15 squared is a group of 2 15s. So I'm going to circle my groups of 2 in each one of these. Okay, nothing left in the first radical. There's nothing left under the radical, so I have a 3. There is a 5 left under the second radical. I'm going to pull that 3 out with a 5 remaining, pull the 3 out with a 5 remaining under the radical. Then I'm going to pull the 15 out, and there's nothing remaining under the radical. So I do have like terms. A positive 3 and a positive 15 is 18. And then I have a negative 3 radical 5 and a negative 3 radical 5. So that's a negative 6 radical 5. And that is my final answer. So we're going to do the same thing for the next binomial pair. So I'm going to multiply, distribute my first term across, and I'm going to get, when I have numbers on the outside of radicals, I multiply the numbers on the outside. So 4 times 5 is 20. And then I have a square root times a square root, so I'm going to multiply what's underneath. So I get y squared. All right, so I notice when I'm distributing this 4 radical y across this 2, the 2 does not have a radical. So all I do is I multiply the numbers in front of the radical. So I have a 2 and a 4. 2 times 4 is 8 radical y. And then when I distribute the second term, negative 8, across both of these terms, I get a negative 8 times a 5 is a negative 40 radical y, and a negative 8 times a positive 2 is a negative 16. So how do those radicals reduce? Well, y squared is a group of 2 y's, so I'm going to pull a y out. So I get 20y with nothing remaining under my radical. 8y does not reduce, or 8 radical y does not reduce. Minus 40 radical y does not reduce. And minus 16. So now let's look for like terms. I don't have any like terms for 20y or for negative 16, but I do have 2 like radicals that I can combine. So it's 20y minus, let's see, 8 minus 40 is a minus 32 radical y minus 16. All right, so that is the answer for that one. All right, so let's move up. And let's go ahead and do this next problem here. Oh Lord, what happened? Here we go. Okay, so let's go ahead and do this next problem. Let's make this a little bit bigger. All right, so now I'm going to be multiplying cube or binomials that have cube roots. So I'm going to distribute this cube root across both of these terms. So the cube root times a cube root, they have the same root, so I can multiply what's underneath. So I get the cube root. B times 2b is 2b squared. And then when I multiply the cube root of b times the 7, I multiply the numbers in front. Every root has a number in front, and that number is 1. So 1 times 7 is 7, a positive 7, cube root of b. And then I'm going to take the second term and multiply it out. Negative 2 times the cube root of 2b. So negative 2 times 1 is negative 2. And then I still have my cube root of 2b. And then a negative 2 times a positive 7 is a negative 14. So can I reduce? I do not have a group of 3 2's or 3 b's, so that does not reduce. For the second one, I do not have a group of 3 b's underneath, so that doesn't reduce. Again, I do not have a group of 3 2's or 3 b's under this one, so that does not reduce. So I believe this is my final answer because none of my radicals are exactly the same. I cannot combine them. So how do we do this next one? Well, we're going to distribute, use our FOIL again, just like in our other problems. And because I have cube roots, I can multiply what's underneath. So I have the cube root of 12 times 4, which is 48. And then the cube root of 12 times negative 1. So remember, there's a number in front of that cube root of 12. It's 1. So 1 times negative 1 is negative 1, cube root of 12. And then when I multiply positive 3 times the cube root of 4, there's a number in front of that cube root of 4. So that number is 1. 3 times 1 is 3. And I have a cube root of 4. And then when I multiply a positive 3 times a negative 1, I get a negative 3. All right, so let's see if we can reduce. 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. All right, so how do I reduce 12? 12 is 2 times 6, and 6 is 2 times 3. How do I reduce 4? 4 is 2 times 2, and then my minus 3 goes out here. All right, so I can't reduce this one because there's no group of 3, and I'm looking for groups of 3. I can't reduce this one because there's no groups of 3. But in the very first one, I have a group of 3 2s, so I'm going to pull out one of those 2s, and I get 2 cube root of what remains underneath. 2 times 3 is 6, minus the cube root of 12, plus 3 times the cube root of 4 minus 3. And I notice none of my roots are like, so I can't combine anything. So this is my final answer. And it looks like we have time for maybe one more. If we have more time than that, then we'll do another one afterwards. Okay, so let's take a look at this one right here. This time we're gonna distribute a binomial across a trinomial and see what happens. All right, so I have all cube roots, so we can multiply what's underneath them. So let's take this cube root on the outside and distribute it across all 3 terms. So the cube root of what's 2x squared times 4x, I get 8x cubed. And then I have a 1 in front of this, remember? So 1 times 5 is 5. And then 2x squared times 2x is a 4x cubed. And then when I distribute across this negative 3, what's negative 3 times positive 1? Negative 3. And then I end up with the cube root of 2x squared. So let's see if anything reduces. Well, I know that 8 is 2 times 4, and 4 is 2 times 2. I know that 4 is 2 times 2. And let's see, in this last one, I just have a 2 because that's already prime. So how many groups of 3 do I have here? I have a group of 3 2s and a group of 3 x's, so they both come out. So I get a 2x plus, I only have a group of 3 x's for the second one, so an x comes out. 5x cube root of 4. And I don't have any groups of 3 in this last one. So the cube root of 2x squared. So if I take a look at all of my terms, I have no like terms, so I am done with that one. And we do have time for one more. We'll see if we can get through it. All right, so let's go ahead and distribute this first term across all 3 of these. And they're all cube roots again, so I can multiply them. So I get the cube root of y times y squared is y cubed. Okay, I have a cube root. What's y times y? Y squared. And then 1 times 1 is 1 cube root of y. So now I'm going to take this negative 1 and distribute it across all 3 of these terms. Sorry for the phone. I get a negative cube root of y squared, and then a negative cube root of y, and then negative 1 times a positive 1 is a negative 1. So let's see. Do I have any like terms? Because I think I got some that cancel out. I have a positive cube root of y squared and a negative cube root of y squared. They will reduce out. I also have a positive cube root of y and a negative cube root of y. They will reduce out. And in my very first cube root, I notice that I have a group of 3y, so I'm going to move that out. And I get y. And I still have this minus 1 at the end, minus 1, and I am done. And those are the examples you should be looking at so that you can do your homework correctly for tomorrow's assignment.